Okay, we're in example number 11, and it comes in multiple parts, and that's a problem in itself, by the way. I'll write it down for you. It's the limit as h goes to 0, and it's going to be 10 plus h squared minus 10 squared over h. And what they want me to do is they want me to find out what it is, what derivative it is. Looking at it, I'm going to say, looking at the function, I'm going to say it looks like the function is x squared. And it looks like the a value is going to be 10, all right? So I just want to make sure you understand, if I were to do that, I would write that down. So I'm going to say, what do they want to know? What's the derivative, and where's it being evaluated? So I got the function, I got this derivative over here. So I'm going to say this is f prime at 10, with the understanding that f of x is x squared, all right? So let's just check it out. And what would you do over here? You know, limit h goes to 0. Whoops, doesn't look right. You know, f of x plus h minus f of x over h. You get the idea, right? You could also write down, this is f prime. You could write down f prime at 10. What's that going to be? Limit, let me get my eraser out, go backwards. Limit h goes to 0. This is f of 10 plus h minus f of 10 over h. I'm just checking. What do you get over here? Limit h goes to 0. Well, what's the function? I said it's x squared, right? So you can get 10 plus h squared minus 10 squared over h, which is exactly what we expect to come up with, all right? Let's do the next one. This is letter B now. We're still in example number 11. And again, limit, and you're going to get better over time, by the way, goes to 0, and it's going to be 2 plus h to the 6th power minus 64 over h. Well, I'm going to rewrite it a little bit differently. I write limit h goes to 0, and this looks like 2 plus h to the 6th power minus 2 to the 6th power over h. Let me just check it out. 2 times 2 is 4, 8, 16, 32, 64. That does work out. And I'm looking at this thing and I'm saying, oh, f of x looks like x to the 6th power, and the a value looks like 2. So really what we're doing f prime at 2. What would that be equal to? Limit h goes to 0. Well, let's write this down. It's going to be 2 plus h to the 6th power minus 2 to the 6th power over h. So this looks good. So again, what do they give me over here? This is f prime at 2. That's what they're giving me, all right? And the function they're giving me is this one over here. All right, let's go to C. Well, let's take a look at it. Limit h goes to 0. I kind of like that definition, by the way. And this is going to be the square root 16 plus h minus 4 over h. Well, I want to write it a little more familiar to me. Limit h goes to 0, 16 plus h minus the root of 16, which is 4, by the way. So I'm starting to recognize this as a derivative at 16. All right? Then the question is, what's the function? Well, looking at it, what's the function? It's the root of x. All right? That one's done. Let's go to D now. What's D going to be? Limit h goes to 0. I'm just copying it over again. 1 over 5 plus h minus 1 over 5. And they're not really trying to confuse me at this point. I see this one right away. I'm going to say this is f prime at the number 5. What's the function now? That's what they're asking for as well. Looks like 1 over x. All right, that one's done. Let's go to E. And what's E going to be? Oh, it's terrible. They use a different symbol. They use this delta x business. Delta x goes to 0. All right? Let's write this one down. And it's 1 over, it looks like 5 plus delta x minus 1 over 25. And what do you get over here? Delta x. All right? Now, I'm not a big fan of the delta x, so I rewrite it limit as h goes to 0. This would be h, and this would be 1 over 5 plus h. You don't have to do this, by the way. And I'm going to write this as 1 over 5 squared. So I'm recognizing this as a derivative now. It's f prime at 5, with the understanding that f of x looks like 1 over x squared. All right, and that's letter E now. We have a bunch to get through, by the way. Let's keep going. Next one, we go to letter F now. And letter F is the limit. H goes to 0. This looks like the tangent, pi over 3, plus h. And then they got this minus root 3. What do they get in bottom? H over here. Well, I'm going to rewrite it. Limit. H goes to 0. This is h. This is the tangent, pi over 3, plus h. And I'm going to say this really should be the tangent of pi over 3. Let me just review this with you. Pi over 3 is the same thing as 60 degrees. And 60-degree triangle looks sort of like this over here. And what would you have there? Well, this would be 2, that would be 1, that would be root 3. So yeah, the tangent of pi over 3 is going to just simply be the root 3 like I said it was. So I can immediately recognize that this is the derivative of the tangent function at pi over 3, with the understanding that f of x is the tangent of x. That's letter F. Let's go to letter G now. Hope I'm not losing anybody here. Limit h goes to 0. This is E, or Euler's number, to the 8 plus h minus e to the 8 over h. Well, I'm kind of recognizing that. And what I recognize is this is a derivative at the value 8. What's the function now? Whoops, I didn't mean to put that down. The question is, what's the function now? F of x is e to the x. All right, that's letter G. And let's go to letter H now. I get dizzy looking at all these problems, by the way. The limit, h goes to 0. That's a natural log of 15 plus h minus the natural log of 15. These are written so there's really no confusion over here. I'm going to say this is a derivative of a function. We'll talk about the function in a moment at 15. What's the function? What's f of x? It's the natural log of x. All right, let's keep moving. Let's do I now. And I is a limit as x goes to 6, and it's 1 over x minus 1 over 6, and then x minus 6. All right? Now this is written differently than the other one. It's not an h, by the way, but it's like, sort of like that other definition of derivative that we have. So looking at this thing, I'm going to say this looks like the derivative at 6, all right? With the understanding that f of x, and I'll check this for you, is 1 over x. So if I were to do that and write down f prime at 6, and I want to use that definition that we've been using prior, this would be x goes towards 6, the function 1 over x, minus the function of value at 6, which would be 1/6 over x minus 6. Certainly stands to reason, by the way. That was letter I. Let's go to letter J now. And letter J is the limit as x goes to 8, and then it's going to be the square root x plus 1 minus 3. And what goes over here? X minus 8. I'm going to write this a little differently. You don't have to, but I am going to write this differently. I'm going to use the root of x plus 1 minus the root of 9. And this is going to be x minus 8. So I start to recognize this, that this is a derivative at the number 8. And I'll check it out in a moment, by the way. With the understanding that f of x, is the root of x plus 1. Let me just check it. And what are we going to say? F prime at 8 would be the limit as x goes to 8 of f of x, which is the root of x plus 1, minus that function evaluated at 8, which is the root of 9, over x minus 8. And that stands to reason. So that one's done. That's letter J. Let me make sure, looking over that. Yep, letter J. We just did that. Let's go to letter K. And that's going to be limit. X goes to 0. And this is e to the x minus 1 over x. I'm going to read it a little differently. It looks a little strange to me. I'm going to write as limit. X goes to 0. I'm going to write this as x minus 0, e to the x minus e to the 0. Same meaning, by the way. I recognize this as a derivative at 0 of the function f of x, and I'll check this for you. That's e to the x. Let's just check that. So f prime at 0 is the limit as x goes to 0 The bottom's going to be x minus 0. The top's going to be e to the x minus e to the 0. Yeah, it stands to reason. We got that, k. Let's go to HIJKL. Oh, boy. What's L? Limit. X goes to 1. And you're getting x to the 10 minus 1, x minus 1. Well, I'm going to write it, again, I'm going to write it a little differently. I'm going to write this over here. Limit x goes to 1, x to the 10 minus 1 to the 10. All right, looks more in line with what I expect. I can say it looks like a derivative, evaluate at 1, with the understanding that f of x is going to be x to the 10th power. Let's just check it out. F prime of 1, what's it going to be? Limit x goes to 1, x10 minus the function evaluate at 1, which can be 1 to the 10th power over x minus 1. Certainly stands to reason, and that was letter I. I'm sorry, what letter are we on? So make sure I'm HIJK. Oh, I'm sorry, letter L. Sorry about that. Let me just look at where we are in the notes, by the way. So we're on letter M now. And what's that going to be? Limit x goes to pi over 2. And this is sine. I'm sorry, it doesn't say that. I want to write down the things I'm not saying. X minus 1 and x minus pi over 2. Again, I'm going to rewrite it so it looks like what I expect it should be written as. And that'll be sine of x minus the sine of pi over 2. And then you get x minus pi over 2. That's what I'm expecting it to look like. What's the sine of pi over 2? It's just simply 1. So this looks like a derivative. I'll write this over here at pi over 2. What's the function going to be? The function f of x is the sine of x. All right? We've checked enough of these already that I think you're pretty comfortable that that's a correct answer. That was letter M. And let's keep moving. Let's go to letter N now. And that's going to be limit x goes to 7. On the bottom you get x minus 7. And on top you get the cube root of x plus 1 minus 2. So I'm looking at this thing and I'm wondering, can I write this in a different way so it looks more familiar to me? I think so. And let's write this over here. X minus 7 cube root x plus 1 minus the cube root of 8. And this looks like a derivative to me at 7. The question is, what's the function? Well, the function is going to be the cube root of x plus 1. If anything's confusing at this point, it might be this thing over here. But if x is 7, x plus 1 would be 8. So it stands to reason. So that was letter N. And now we'll move on to the next one. And let me just make sure we're moving along okay. And we'll go to letter O now. And what's that going to be? Limit x goes to 1. And what do you get here? You get x cubed plus 4x minus 1, and they put a cube over here. I guess they're trying to help me, right? I don't know if that's going to be helpful, by the way. And then over here, you know what? I don't think I should do that either because that would really confuse me to do that. Let me get my eraser out again. And I have to look at the problem to know what they're doing over here. But I'll write down, I should write down exactly what they have, by the way. So minus 1 cubed and then plus 4 times 1. So I guess they are trying to help me, by the way. What goes on bottom? X minus 1. I'm going to rewrite it a little differently. I'm going to write as limit x goes to 1. And this is going to be x cubed plus 4x. I write this as minus, I'm going to write it as 1 cubed minus 4. I'm not going to put the times 1 down over x minus 1. And I'm going to say, 1 cubed minus 4, you could put that down too. It's minus 3. It doesn't really help me that much. But I'm looking at this thing, and I got to make an assumption that this is a derivative over here. I'm going to say derivative evaluate at 1. And someone says, what's giving that away? This is giving that away, right? Now I'm going to say the function. I'll write this down for you. And the function I'm going to check this, is x cubed plus 4x. Let's just write this down. So f prime at 1 is going to be the limit as x goes to 1, x minus 1 in the bottom, x cubed plus 4x minus, I have to evaluate the function at 1. And what would you get over there? You would get 1. Whoops, I think I made a mistake over here. Let's make sure I put that down. That's a plus sign. Sorry about that. That would be 1 plus 4. And where's that being evaluated? Right over here. And I did correct that, by the way. So it's, 1 cubed plus 4 because we're subtracting it. So I'm comfortable that's done. And we're going to move on to the next one, which is going to be letter P. I think that's the last one. Let me just check to make sure. Yeah, that's it. And then we'll take another tiny break and move on to the next set. So P, let's see, limit as x goes to 1. Now, before I say anything, I'm going to say, I hope this is like f prime at 1. Let's write this down. What do you get over here? You get x, and you get 3x plus 2 minus 1 over 3 times 1 plus 2 over x minus 1. Yeah, this seems to stand to reason, by the way. What's f of x going to be? It's going to be x over 3x plus 2. Again, they're asking us to come up with two different things, what the function is and what the derivative is, and we did that, all right? So we'll take a break, and let me just make sure we just did example number 11. It was kind of a lengthy process, by the way. We got through them all, but now we'll go to example 12, and we'll move forward. And next thing, I'll probably go to example 12 through something, and then we keep doing it in chunks, by the way, reasonable chunks. Thank you.